Hello and welcome to SAE Tomorrow Today. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have James McMicking, Vice President of Strategy, ZeroAvia. On today's episode, James and I discuss the future of zero-emissions aviation. And you won't believe this, it's only a few years away, not 10 years away. We hope you enjoy this episode. Welcome to the podcast, James.
Hi, good to be here.
It's wonderful to have you here because what ZeroAvia is working on is the future. What ZeroAvia is working on will have a profound positive effect on society as we move towards a decarbonized world. And staying on that theme, James, how will zero emissions aviation be achieved?
Sure. So, first of all, when we say zero emissions, what we mean is zero climate impact. And that's really important to distinguish here. So to get there, we've got to stop fundamentally burning things, okay? Because when we burn things, then we create emissions of one variety or another. But it's going to take time. So the industry is obviously looking at a whole bunch of different solutions in order to transition to a zero emissions future. We think that hydrogen is going to be the fuel that gets us there ultimately. And there are two things you can do with hydrogen. You can either combust it through a turbine, or you can run it through a hydrogen electric system, which is what we're developing. So this is a fuel cell, turns that hydrogen into electricity to drive an electric motor. The difference between the two is one case you're burning the hydrogen, so you're creating nitrous oxides, but also a lot of high velocity, high temperature water vapor. With hydrogen fuel cells, we don't burn it, so there's no nitrous oxides, and the water vapor leaves the aircraft at a much lower temperature and lower velocity. Which means we can do things to potentially manage and mitigate contrail formation from using hydrogen as a fuel. So that's the direction we think things are going in, and that's how we get to a genuine zero-emission aviation industry.
How does hydrogen fuel cells, the role that it plays as it relates to weight, does it make the plane heavier than if you're using traditional jet fuel? Is it lighter? How does that work?
Yeah, so it's all very different to the sort of aircraft we understand today. So jet engines are very power-dense devices, of course. And with the technology today, we don't have that same level of power density from the fuel cell. But the idea is to develop the technology so we get closer and closer to that mark. The trade with the system then is you end up with a heavier propulsion system, generally speaking. But the fuel is a lot lighter. So hydrogen, is significantly lighter than kerosene for the amount of energy that you can extract from it. So that's where you get something back, if you like, at the airframe level. So overall, we aim to be able to maintain an aircraft that can carry the right sort of payload and fly the right sort of range with this type of powertrain in the relatively near future. And then it's all about increasing that power density using developing technologies and scaling those technologies up to then operate with hydrogen.
What type of range are you looking at when you first roll out your product?
Yeah, so the very first product is going to be a commuter type aircraft. So this is in the 9 to 19 seat category. And this will run on gaseous hydrogen and operate somewhere between 250 and 300 nautical miles of useful mission range. And when we eventually introduce liquid hydrogen into the sector, we'll be able to extend the range of those aircraft as well beyond that. So that's through retrofitting of aircraft. Okay, so that's taking an existing airframe out of the fleet, removing its turbines, and then putting a hydrogen electric system in. If you go with a clean sheet aircraft in that sector, then you can fly a lot further because, of course, you can design the plane to use the powertrain more effectively. And we've announced fairly recently partnerships with Aviation, for example, that has a novel type of airframe that is very efficient and can package this type of powertrain more effectively than the retrofit. But the retrofit is a very viable solution. It's a way of decarbonizing quickly, sooner, the sector. And then what we'll do is we'll increase the power ranges at which the technology can work. The program we're also undertaking at the moment is for regional turboprops. So this is the sort of 40 to 90 seat category. And here we'll use liquid hydrogen, and we'll want these aircraft to fly up to 1,000 nautical miles eventually in retrofit form. So these are distances that cover more or less all of the missions that these types of planes are flying today.
When you're looking at the 250 to 300 nautical miles, you're based in London. You have Heathrow Airport. Is that say from Heathrow to Madrid, or can you give like an example of what that distance might be so a listener can relate to it?
Yeah, so the commuter aircraft don't tend to fly that far anyway, right? Because they're relatively slow. They're small planes. You use them to connect places that are not well connected. So in the UK, as an example, it would be something like flying from London to say Scotland, right? To Glasgow or Edinburgh, or you could fly across the country, maybe from Birmingham to Norwich, and connect regions that are actually not that well served with ground infrastructure, and cut journey times to maybe a third of what they would otherwise be, and probably do it at significantly lower cost. So, actually the technology has an interesting role in that space, in those small aircraft. And that's where we end up talking about things like regional air mobility and new forms of using aviation to help connect regions. If you want to fly to the Med, then you're going to need to wait for our regional turboprop powertrain technology. So when we're pushing 1,000 nautical miles, that's the sort of plane you want to go on holiday from the UK down to the south of France or Italy.
Regional mobility aircraft is going to have a positive economic impact. So if you go into a part of Scotland or you go into Wales, you have a positive economic impact from the tourism dollars that those individuals are spending there, and you're going to get them there in a very clean, efficient way. Which raises the question I've thought a lot about, is the infrastructure there. Do you have to put hydrogen fueling infrastructure at these regional airports, or what does that look like as you get prepared to scale up your service?
Yeah, absolutely. So in a lot of cases, you don't need to put the infrastructure everywhere, because the aircraft can tanker the fuel from a hub location to the airport you want to travel to and back again. So many of these flights are less than 100 nautical miles, right? Over either a sort of mountainous region or over a short stretch of water to connect to an island. So there's plenty of fuel on board to do that journey out and back again. So that's useful. That helps ease the infrastructure problem. But we are working on infrastructure solutions alongside our powertrain technology development. We have in our facility in the UK in the Cotswolds our own mobile refueler, but we've also developed a refueling pipeline that I think is the first of its kind, running from landside to airside. And we can manage end-to-end the production of hydrogen right the way through to refueling the aircraft itself. So we already understand the protocols and how this can be achieved safely, of course. And that way we're sort of already solving some of these operational challenges. And we're going to do that infrastructure work with partners to roll it out in different ways. You'll see different infrastructure solutions depending on the particular circumstances of the airfield, how much hydrogen it needs, what its proximity to power generation is like. You may see on-site generation, of course, both with renewable power and electrolysis, but you'll also see off-site centralized generation of green hydrogen and tankering in or piping in even at large volumes to the airfield.
That opens up the wonderful opportunity for microgrid. You can generate it completely using renewable energy, which can then help further cut down on the carbon. From a refueling, you're on a commercial airport. You look out the window, you see the team. They plug it in to fuel up the aircraft before you go on your journey. How does that compare to fueling up with hydrogen? Is it a different safety procedure? What does that look like?
It's going to be a bit different, absolutely. So, hydrogen as a substance has different safety considerations to take into account, which means, potentially different safety distances need to be observed to the airframe. You've got different sort of human factors considerations as well, and how we need to protect people that might be operating with equipment. So things will look a little bit different, but I think to the layperson, you'll see hoses being plugged into the aircraft. You won't see what goes on inside those hoses, and then they'll be unplugged and you'll board the plane. So there won't be a lot different in that respect, but the equipment and the procedures will be quite different. So there is a reasonable amount of work there to do in understanding all of those things and establishing the standards. But all of these challenges can be reasonably overcome, and they've been looked at in fairly good detail so far by folks looking to develop these technologies in the sector.
That's a very interesting point, because you got kind of a theme of this podcast is about public trust. So today, a consumer or passenger, for that matter, is very comfortable going on a traditional jet with jet fuel. They're on a hydrogen plane. Will they even notice a difference from an experience on the aircraft? Or will they okay, this could be jet fuel, we don't know. Will they notice any difference?
They probably won't notice any difference, to be honest. I mean, what they will notice with our aircraft, particularly the smaller ones, which are the propeller aircraft, right, is less noise. So you'll hear the prop noise, but you won't hear the turbine noise. So the propeller will start spinning very quietly until it spins right up, and you'll get that. But none of the other stuff that comes with it. Probably less vibration as well through the airframe, I would expect. So this is another thing that kind of makes it interesting, right? Back to our regional mobility argument earlier. You've got a zero-emission powertrain. It's got no impact on local air quality because there's no nitrous oxides, which is one of the most problematic gases when it comes to health, and lower noise. So those things are important factors for local communities. So if we want to start using airfields for increasing our mobility between different regions, these are the sorts of things that we'll need on aircraft to make it acceptable to use them. So they will notice these sort of differences, hopefully an enhanced passenger experience. And again, those that are particularly well versed in what aircraft look like, you'll notice some other differences as well, like engine nacelles are going to be slightly different shape. On bigger aircraft, they're going to be shaped differently to hold fuel tanks in different places. The wings will be redesigned to improve the aerodynamics, all this sort of stuff. But you'd have to know what you're looking for to see the difference, I suspect.
It's neat. There's that wonderful video. Well, I think it was a month or two ago at Heathrow. There's these individuals out there, and they were plane spotting, and the gentleman's calling it like a football game. Oh, this one, he's banking to the left, he's banking to the right because of the winds. And it was really impressive. There's this group of individuals that love aircraft, and they try and spot them. So that's on the consumer passenger side. How about on the pilot side? Will the pilots have to go through retraining, or what will the difference be from a pilot that's going to fly one of your aircraft?
Of course, there will be a different system to manage for the pilot, and the instrumentation is going to need to give different feedback in the cockpit to the pilot. So there's going to need to be a rating that goes with that system. So the pilot will need to be trained in the system, in the safety procedures that go with it. So this is something that we're working our way through as we flight test the aircraft. And this is one of the reasons why we want to work with operators to understand what they need from us to introduce these aircraft into service. So you're absolutely right. Not just pilots, but the rest of the crew, the ground crew, maintenance operatives as well, and technicians are going to need to be trained in how to service these types of engine as well.
Operators that operate, you're in the UK, so you have British Airways, then here we have American, we have United, we have Delta. These individuals understand large, sophisticated operations. They understand all the maintenance. They understand the painting, the regulatory. And I want to give you a shout out here because you're based in the UK, but in America, you have a 19% market share on paper. You've got a deal with Alaska Airlines and a deal with United Airlines, which combinedly gives you 19% market share of the U.S. With Alaska, so the deals with the Alaska Air Group, which is the parent of Alaska Airlines, you're going to develop a hydrogen electric powertrain capable of flying a 76 regional aircraft in excess of 500 nautical miles. Another shout out, Alaska's also an investor, so congratulations on that. So you're working with them as an investor and as a partner. Could you talk about that collaboration? Because it seems like something special is brewing there.
Yeah, absolutely. So, I mean, this is back to the regional turboprop we talked about earlier. So, we want to retrofit aircraft for Alaska with hydrogen electric powertrain. So they're going to help us with understanding their requirements for the aircraft, because obviously we're making significant changes to the airframe, and we want to optimize that system. So, having these customer relationships is really important. They want to take a leading stance on decarbonizing their operations, which is fantastic. And, it's good to see these big operators wanting to be first movers with the technology. And it really helps us as innovators to have access to them. So, that's what that's all about. And obviously coupled with it is, our relationship with de Havilland of Canada, for example, on the airframe itself. And, that way we've got the technical partners we need to bring that aircraft into service. And, the target is to do that in more or less 4 years time. And, they'll be set up with zero emission operations shortly after. So that's what we're doing with Alaska. And it's also some British airlines. I mean, you've mentioned British Airways. They're a strategic investor and a partner in the business as well. But, they're obviously looking, and I think this is an important message here, they're looking to where the technology is going to go in the future, right? Because they're interested in bigger aircraft. And that's absolutely the mission of the company. This is scalable technology that in time we're going to be able to power larger aircraft that will really help these operators to decarbonize.
We've all done it. We go across the pond, so you go from JFK to Heathrow. Is that the thing? Okay, I believe it's their most, I have to look at their financials, but it's their most profitable route. Do they also want to make that their most decarbonized route?
I imagine so. I can't speak for British Airways, but I should think they want to decarbonize everything they're doing. But particularly these long range flights, right, which use a lot of the fuel in the industry. So those things are absolutely in scope for hydrogen propulsion. There are no barriers to really the range in which these aircraft can fly. At least hydrogen aircraft can service all routes. Concept work that has been done to look at this in some detail within the UK, for example, by the Aerospace Technology Institute, has shown that you can design a hydrogen-powered aircraft to fly anywhere in the world with one stop, right? So that is commercially viable for the entire industry's requirements. So, this is why it's exciting. Now, how you use that energy is this debate between turbine and hydrogen electric, or potentially a combination of those two things. So, this is where the technology is going to go. We're going to keep scaling it up to try and power these bigger and bigger aircraft, because that's how we make a real impact on carbon emissions.
Qantas operates the world's longest flight. It's just over 20 hours directed. I forget where it starts and goes. I think it might be Dubai to Sydney. Is that the holy grail for where you're trying to say, aha, we've done the longest route with hydrogen in the world?
No, I not for me at least, and that's not something that we're focused on as a powertrain business specifically, because it's unusual to fly that distance, right? And I think if we set out to design aircraft to do that specifically, we're missing an opportunity to do things much more efficiently with the rest of the sector, right? Because you've then got to design your entire aircraft family to do that one task for a very select number of occurrences. That's why the retrofit is actually working quite well, because we're taking airframes that can fly a lot further but never fly that distance, or very, very rarely do. We retrofit them and make some compromises with the aircraft in doing so, but we end up with a viable solution because it still flies the distance that operators are actually flying the plane. So I'd like to see in the next generation of aircraft, real consideration on the design points, how far these things are going to go, and let's design something really, really efficient.
When you retrofit an aircraft, does it have to go through a recertification process with the FAA or the equivalent in the UK, EU? Yeah,
that's right. So the idea here is to get a supplementary type certificate for the aircraft to do the modification, like would be the case, say, for cargo conversions or other substantial changes to the airframe. So we will have to go through a process with the regulators to get that supplementary type certificate. We'll also need to have type certificates for the different elements of the powertrain. This is where it's a little bit different to turbines again. You have the electrical propulsion system, and there are conditions out there that govern the certification of those today. But then you've got the fuel cell power generation system, and that's new territory. So we need to develop the regulatory means of compliance for that so we can type certify it. What we're doing in the UK is working very closely with the UK Civil Aviation Authority in our research and development programs to exchange views on how we do that and what the means of compliance need to be as we go through our development process. And that's working extremely effectively alongside how we're maturing the technologies. So we need that process to obviously complete in time for us to then go through the certification process itself, demonstrate the aircraft is safe, the engine works, so we can go to market with it.
In general, what are the regulators' thoughts on a hydrogen electric powertrain? Are they welcoming to it? Are they skeptical? What are their general thoughts?
I'm not sure I can answer the question, to be honest, because I've not asked the regulator. But I would say we're getting good support from the UK's CAA. They want they're interested, and they want to understand the technology and get clarity on how we make it safe, of course, and that's what we all want. So I would say no feedback, good, bad, or otherwise, but we've got good engagement with the regulators on this, and obviously they're supportive of helping the sector to reduce its climate impact.
It has to help when you have United Airlines. They placed a preliminary order for 50 ZA 2000 RJ engines with an option to purchase 50 more. Is that helping that? Saying, okay, here's, I believe, second largest airline in the world that's basically validating your technology. Is that helping?
Yeah, well, again, I kind of difficult to answer, but I should think so, right? Because these things send clear messages that this is what the industry wants, and the industry is being asked to address its climate impact in increasingly more urgent ways, I would say, either through biofuels, but it needs a sort of longer term plan, and that's what this technology is doing. It's giving them a pathway to something truly sustainable. So I think it sends the right messages, and I think it demonstrates that we've got all of the key stakeholders engaged in the development process as well, which is really important. We're not doing this in isolation, and we're not missing a piece of the puzzle. We've got the operator, the airframer, the infrastructure partners, and you bring all of that together, then you can make sure you're developing a solution that's going to be viable and should be certified. So I think that does help for sure.
Because United, for the listeners who are not sure what it stands for, RJ stands for regional jets. That's the United term that they use. Have you sat down with United with your technology around the hydrogen electric powertrain and say, okay, this would be a really great, United says, okay, these are very, let's say, give you an example, Chicago O'Hare to Louisville, that's an RJ route. Or Chicago O'Hare to Cleveland, that's another RJ route, and saying these are routes that we like to start decarbonizing. Is that how that technology is going to be rolled out, or what does the process look like?
So that process will be somewhat iterative, as you've described there. Let's see where the technology can be applied sensibly. Again, thinking about range limitations and how to optimize this first generation of product. I mean, I'll sort of change course slightly with the question to say, we have a relationship with Mitsubishi Heavy Industries, RJ, obviously that the manufacturer of the plane, right? Or at least the owner of the plane. And that's where we're focusing a lot of effort with them on the technical side, right? How do we do this in the right way? What does the solution need to look like? What are the requirements of the system? So we're very much focused on the technical aspects at this point, I would say. But absolutely, we talk to the different operators and say, okay, look at your routes. Where is it viable? Where should we start? And it's not just looking at what their schedules are, but what is the infrastructure impact? Again, back to infrastructure. What is the infrastructure solution that goes along with those different routes?
You have all the building blocks. You have the relationship with Mitsubishi Heavy Industrial, the manufacturer of jets. You have it with the operator. That seems like that's to give you a clear advantage to perfect and eventually scale your product.
Absolutely, yeah. That's the idea. So we've got the right partnerships, the stepping stones as well in place. So the ZA600 commuter, then into the turboprops with the ZA2000, and then it's another level of power for the regional jet, of course, supported by behind the scenes a technology roadmap in both the power generation system and the electrical propulsion system to achieve those products as we go together with the infrastructure. So it's a sort of stepping stone approach to scaling the technology, and each stage you learn a lot and you incorporate that in the next stage. And as we go, we are going to bank significant hours of experience, operational experience. I haven't done the sums, but by the time we get to the RJ, we will have banked tens or hundreds of thousands of hours of operational time in hydrogen electric aircraft. So this is gaining that experience as quickly as possible is very important in this industry. That's where you demonstrate the reliability of the system. You understand your commercials really, really well. And that's important as you go up into these bigger and bigger aircraft, of course.
Experience builds trust. And that's really where it starts with, because if you're sitting there and you're meeting with an individual at Mitsubishi Heavy Industrial, okay, so you're working on this, you're retrofitting, you're modifying, you take them for a flight. Oh, wow. Okay, so you just started to develop that trust. Exactly.
It's all about trust, And and demonstrating the maturity of the business as we go. This was a company that was started just 4.5 years ago, and you have to work hard on building the brand, which is of course trust, and developing the business in a way that is transparently respecting the standards of the industry, that is adhering to all of the right safety requirements and quality requirements. So that's also important behind the scenes, and companies only want to work with you if they can see those things happening and they understand the journey we're on in that regard. Okay, we're scaling up very quickly, but just within the last year, the business has matured in so many different dimensions, and it comes from the experience of having to certify these aircraft, for example, for just experimental flights. We go through significant procedures and documentation with the CAA to get permission to fly in the UK. It's one of the more rigorous environments in which you can do experimental flying because the nature of the place. From an innovator's perspective, it can be a bit frustrating because you want to go quickly, but it's absolutely healthy for the business that we're going through that. It prepares us for subsequent type certification down the road, and has helped us to mature all of those internal processes and procedures and the organizational structure that you need to go with that. And certainly the feedback we've received from the authorities and from customers is extremely positive about where we've got the business to so far.
You want to go through that today, not 5 years from now, 10 years from now. It's
Absolutely.
You've got a big surprise.
Yeah, absolutely.
So you want to go through that now. I mentioned earlier you have a 19% market share of the U.S. airline market. Very well done. Very impressive. You're the vice president of strategy. How are you planning to grow that market share?
Oh, well, so we need to sell more engines to more operators. That's how we do that. But again, it's the stepping stone approach, right? So we expand our market by developing bigger and bigger engines, retrofitting those as far as we can in the market, and addressing segments of the market where those retrofit solutions are most viable. So, we're pretty focused right now on where those locations are, or who the operators are, what the airframes are. And as the technology becomes better and better, we can push out the market, right? We can increase what we can capture. So, that's the approach. Scale the technology, keep moving through the airframes. And, the idea is once we've got a certified ZA600, that is going to go onto multiple commuter airframes. Once we have a certified ZA2000, that's going to go onto several regional turboprops. So that's how we'll push out the technology. And, we'll keep doing deals with the airlines that are most, forward thinking in terms of their decarbonization strategy. And we'll make sure the infrastructure is getting developed alongside that at the same time and addressing that challenge with big partners like Shell, Octopus Energy. These are the sort of folks you need working with you to roll these things out on a serious scale. So that's the strategy, if you like. Keep scaling the technology, accumulate the test time and the trust as we go, and then we'll win the orders in the market. So that's the approach.
So when you say you're going to go into an aircraft, let's say you're going to sell it to United or Delta, will that be used for paying passengers, or will that be used in a quote unquote test fleet?
No, absolutely. No, these will be. We will take customer fleets to retrofit them and return them to the customer for commercial operations. That's the idea. So clearly, within the development process, we're working with some of these customers through the R&D cycle. That's clearly not a commercial activity. But once it's certified and we hand back the aircraft in certified configuration, it will be taken and used in commercial operations. So we want to put our engine onto different airframes in these different classes, retrofit them, and put them back into the fleet for all sorts of uses. Passengers, but also freight market is another area where we can potentially use this type of technology on aircraft. So again, that's another area that needs to be decarbonized as well, not just passenger traffic.
Just look at the rise of goods being shipped. The market, despite the downturn in e-commerce, now the market's only going to continue to grow. When you let's say you have the customer, okay, ZeroAvia, we want you to retrofit it. Will that be done at your facility, or will you set up a co-location inside of their maintenance facility and do it there where the aircraft is used to, I call it going to sleep or living? Will it be done there?
Yeah, so we're probably going to see a variety of ways in which this is done. We will end up retrofitting at our own facilities. We will do it with partners at their facilities, either a third party that specializes in this activity, or if the airline is big enough and it owns these type of operations, then we'll do it with them. So this is something that we're open to as part of the commercial arrangements we come to with these different customers. And we're exploring those options, right? As you'd imagine. The retrofit generally needs to be done in market, of course, because we are changing the range performance of the airframe. So it's best if it's done at least within the continent, let's say. It's unlikely we'll be retrofitting aircraft in Europe and then sending them back over to the US for operations. So we'll have multiple retrofit centers around the world where we'll ship our powertrains to those centers and they'll get installed into the aircraft. So that's the approach.
Comparing the UK, EU, and US markets, are there differentiating approaches to how hydrogen electric aircraft should and could be rolled out and then eventually commercialized?
Potentially, and primarily because of the slight differences in fleet that you see in these different markets. The North American market has a lot more of the commuter type of aircraft buzzing around than Europe does. The regional turboprops are very prevalent in Europe, whereas the RJs are quite heavily used in North America. So these differences in fleet mix will have an impact on how quickly things get rolled out. Because we're starting with gaseous hydrogen on commuter segment, we're going to see more infrastructure and more routes developed in the North American market first. Okay, so once you've done that, you've obviously started to establish the sort of operations and that you need to support hydrogen electric aircraft. So then it's a sort of generally easy step to then scale that infrastructure and those solutions for the larger aircraft. I think Europe will look a little bit different because it's generally going to be waiting for the bigger airframes to come along, which takes us more into liquid hydrogen in terms of scaling up more quickly. But what we see, that's not to say that there aren't commuter aircraft use cases in Europe. Of course, we talked about regional air mobility and that sort of thing. But what we see in Europe is a lot of government interest and support for developing hydrogen infrastructure, for wanting to support demonstrator projects to enable these type of aircraft to come to market. So, the conditions are good in which to kind of take on that process. So hopefully that kind of answers your question. I think you'll see more prevalence in North America where the smaller aircraft are, and then it might swing back a little bit to Europe. More or less both will kind of develop their liquid hydrogen infrastructure to support the bigger aircraft in time.
Yeah, and then eventually at some point you'll be able to go from the UK to the US, from the EU to the UK to the US. It all works seamlessly. And when you look at seamless operations on tarmac becomes a really big issue. Today, can hydrogen be stored on the tarmac today, or is that going to require policy changes?
It's going to require changes. Yeah, you can't just store hydrogen on the airfield today. So we're going to need to develop the policies and standards around doing that. So there's quite a bit of work to go through. The nice thing with the scaling up approach is again, you start with relatively small volumes of hydrogen. Now that gives you one problem, because it generally produces hydrogen like big volumes because they get economies of scale. But if you've centralized production where there are economies of scale and you truck the hydrogen onto the airfield, you don't necessarily need to put in a lot of additional infrastructure to enable those operations. You need the truck and it needs the capabilities to drive on and refuel the aircraft and then drive off to get more fuel. So eventually we'll need such large quantities of hydrogen that we'll need fuel farms like we see today for kerosene around the airfield. And these things are perfectly feasible in terms of volume, in terms of land area, and the logistical solutions will look a little bit different depending on the types of volumes you're handling. There'll be decisions on whether the fuel gets piped around the airfield as a liquid or whether it gets trucked around the airfield and transferred to the aircraft that way. So these are all the sort of different solutions that will depend very much on the nature of the airfield and the amount of hydrogen it needs to move on a daily basis. But that's a way away. That's the other part of our strategy, is thinking through, like we are with the powertrain, how we step up in terms of power level. how we step up in terms of volume for the hydrogen infrastructure and make that work from an economic perspective and from a logistical perspective. So, that's the trick. But as an airport, the first airports that begin operating hydrogen will use small volumes. In time, they will use larger and larger quantities. So the infrastructure solution you initially had will become obsolete. You'll need to replace it with something else. That doesn't mean that infrastructure is written off. It goes to another airfield that needs lower volumes at the time. So it's a sort of rolling out of a variety of infrastructure solutions in time that makes this work. So that's the approach we're thinking through.
It's a well-heeled approach. I have to give you credit. You're putting the building blocks of the strategy where you have the manufacturer of the aircraft, you have the operating partner of the aircraft. You're clearly understanding the fueling aspects. You're looking at all the standardizations going there. ZeroAvia is clearly putting the pieces together for what a zero emissions future will look like. And putting that together, what does the future of zero emission aviation look like in your opinion?
Well, eventually, it's hydrogen electric all the way. So I think, we see hydrogen becoming the dominant fuel for this industry to achieve zero emission. That hydrogen will be produced through electrolysis type of process. So it will be clean. That's really important in time. There'll be a transition to make there, but there is sufficient resource to tap into to do that, renewable resource, and renewable power is going down in cost all the time. It's already sufficiently low in cost to produce hydrogen at an economic rate for us. So that is the trajectory. And eventually, kerosene fuels are going to get more expensive in our view. They're obviously very expensive today, but as the industry is required to use more and more sustainable aviation fuels, if it's going to get anywhere close to significant quantities, 40 or 50% of fuel use, it's going to need alternatives like power to liquid, and these become super expensive. Hydrogen is just a component part that goes into making an e-fuel. And I think the economics will drive the sector at that point to switch more rapidly. So, you're going to see a tipping point. When the technology has demonstrated it works, when people see the operational aspects have been cracked, the infrastructure problems have been cracked, our planes are flying without emissions at sufficiently sort of credible scales like the regional turboprop or regional jet, then there'll be a call for accelerating that approach for the bigger aircraft as well. So I think that's the direction we see things going in.
And a big part of that call will come from the consumer, because the consumer will demand it. We see it on Google Flights today. This is how much carbon emissions your flight has. And so let's say there's an operator running a ZeroAvia, carbon emission zero, their bookings will go up, and the consumer's going to be a big part of driving that change. And James, I thank you for coming on SAE Tomorrow Today, because I learned a lot about ZeroAvia, learned a lot about zero emissions. And as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Well, I'd like them to take away a sense of optimism for the industry in actually being able to significantly reduce its climate impacts in the future. And the other thing I'd like to say is it's not all as far away as it may seem. The retrofitting approach that we're taking means we're going to see these aircraft taking to the sky sooner than a lot of folks think. Because I think traditionally in this industry, people think of very long aircraft development programs. And for sure, we'll see more of those in the future. But in terms of hydrogen electric powertrains, we're going to get those to market faster than folks generally imagine.
I like that, a sense of optimism. You clearly demonstrated optimism today, because today is tomorrow, tomorrow is today, and the future is zero emissions aviation. James, thank you so much for coming on SAE Tomorrow Today.
You're welcome. It's been a pleasure.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as Carbon Revolution's co-founder discusses the company's carbon fiber wheels that are much lighter than aluminum equivalents and how they are improving steering, handling, and response.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.